Okay, today we're going to talk about Chapter 10, Lesson 5, which is Area of Trapezoids. Our learning objective is you will use a formula to find the area of trapezoids and find an unknown height for a trapezoid. So we're just building on yesterday's lesson. Any parallelogram can be divided into two trapezoids with one pair of parallel sides that are also the same size and shape. The bases of the trapezoids, base 1 and base 2, form the base of the parallelogram. The area of each trapezoid is half the area of the parallelogram. So the bases of the trapezoid, so the area of a trapezoid is half the product of its height and the sum of its bases. So that's nothing new from yesterday, but this time they give us a formula, which you can see there. A equals 1/2, parenthesis, base 1 plus base 2, close parentheses, h. So that's just saying that the base 1 and base 2 are added together first, and then we multiply it by the height and 1/2. So all of that is review, but down here we're going to see a little bit different stuff. So looking at Unlock the Problem, Mr. Desmond has tables in his office with tops shaped like trapezoids. The diagram shows the dimensions of each tabletop. What is the area of each tabletop? So how can you identify the bases? We know that the bases are the two parallel sides. And how can you identify the height? The height forms a 90-degree angle. With bases. So the two parallel sides that could go on and on and on and never meet, those are the bases, and the height forms that 90-degree angle with the bases right there. Find the area of the trapezoid. So let's look at that. So we're going to write the formula. A equals 1/2 B1 plus B2, which is base 1 and base 2, times h, which is height. So then we just substitute what we know. So we know base 1 is 1 6/10, and we know that B2 is 9/10, and our height is 6/10. So then we add within the parentheses. So we're going to add that 1 6/10 plus 9/10, which gives us 2 5/10. And then we would multiply that by 6/10. And when you do that multiplication, you should get 1 5/10. Please check your work and make sure that you understand the multiplication, and ask me if you do not. So then we take 1/2 times 1 5/10, which gives us 75 hundredths. So the area of each tabletop is 75 hundredths. Looking at example 1, we're going to write the formula. Then you're going to follow the same steps. And on your work pages, so your homework or your tests or your mid-chapter check, you need to show every single step of this. This is something that we struggled with, and we need to know where your thinking is. So you need to write the formula every time, then show the step where you substitute everything in, and then you can solve it. So we're going to substitute 4.6, or 4 6/10, for base 1. That's right here. And then we're going to substitute 9 4/10 for base 2. And we put in the height, which is 3 5/10. Then you're going to add 4 6/10 and 9 4/10, which will give you 14. You're going to multiply that by 3 5/10. And 14 times, we're going to multiply it by 1/2 first, because 14 is easily divided into 2, which gives you 7. Then you're going to multiply that by your height, which is 3 5/10, which gives you 24 and 5/10. Again, check your math on that. Make sure that you understand how to add those decimals and then to multiply those decimals. So the area of the trapezoid is 24 and 5/10 centimeters squared. If they do not give you the label, it is very important that you label your work. And final example is the area of the trapezoid is 702 inches squared. Find the height of the trapezoid. So this is the one where the height is unknown to us. We don't know it. Okay, so write the formula just like you always do. Substitute 702 for A, and then you're going to substitute, let's see, we know 1/2 times base 1 is 20, base 2 is 34, and we're going to multiply that by the height. So then we're going to rewrite it after we add within the parentheses, because parentheses are first in PEMDAS. So 20 plus 34 is 54. So now we have 702 equals 1/2 times 54 times h. Go ahead and multiply 1/2 and 54. So 54 divided by 2 is 27. Then we're going to have to move that over to get h by itself. So we're going to have that 27 divided by 27. 27 times h divided by 27. And 702 divided by 27, which basically cancels out those 27s on this side. So you have h equals 702 divided by 27, which equals 26. So the height of the trapezoid is 26 inches. Okay, so the second way to do this is to use the formula h, or height, equals area divided by base 1 plus base 2 multiplied by 2. So then you also need to make sure you remember PEMDAS when using this, because it makes a difference whether you multiply or divide first. So then you plug in what you know. H equals 702 divided by 20 plus 34 times 2. H equals 702 divided by 54 times 2. Okay, correction to that formula. You're going to have to write, actually, it's height equals area divided by base 1 plus base 2 divided by 2. Sorry about that. So height equals 702 divided by 20 plus 34 divided by 2. So then height equals 702 divided by 54 divided by 2. So I'm going to do 54 divided by 2 first. Height equals 702 divided by 27. So then height equals 26, which is what we got the other time too. And remember that that label does not have to be squared because it's not an area.